How y'all doing? Just getting some things set up here. All right, so I think today I just want to continue looking at some of those red team tools. So for those of you who were not here last stream, Havoc was one of the tools that we were looking at, which is written in C. And then we were looking at Sliver, which is written in Golang. So just to kind of look at our notes from last stream, let me pull those up. I don't have too many VS Code windows open. Hey Skeev, how's it going? Hey Everest. All right, yeah, so here's our notes. So yeah, we kind of just got things set up. We generated some payloads using frameworks. Sliver, which is this one here. I'll throw it in the chat. I'm sure if you are in the space, you've heard of Sliver, but and then the other one we were looking at was Havoc here. Yeah, good, thanks. Goose Goof, just wanted to hop on for a chill stream. Get some more work done on these. So yeah, we basically got to the point where we were looking at how Sliver had implemented some of the payloads that we were generating. So we generated a plain text payload in which we were able to easily find the C2 address because it was in plain text. And then we also looked at where the canary domains were implemented. So they have this cool functionality called canary domains, and canaries are basically just fake domains that you can implement in your payload that red teamers can either register or basically look for traffic to, or any indication to that a blue teamer has acquired that canary domain, which in turn indicates that they have acquired your Sliver payload. So we couldn't really get that working. Not entirely sure why. Maybe we can take a look at that again this stream, but it's really not that important because a lot of these payloads, what we really want is the actual embedded C2 payload. And then again, we got Havoc set up. We started doing some function hash resolution. And then what else here? Yeah, and then we basically started setting up our binary ninja database for reversing this Havoc payload. So I started doing this, some of this offline, just because I wanted to get some of that hashing stuff finished because it was kind of boring. So maybe we can look at that first. So if we go back to our hash table generation function here. Again, we figured out that this was the DJB2 hashing algorithm, and we did that with hashdb. And then, so if we look at the cross references for this guy, so I started marking these tables up. So for those of you who do not know, this is a concept called dynamic hashing resolution, in which the export table of loaded DLLs in memory are walked in order to resolve a given function hash. And the way that's done is, maybe we can look at that real quick. I know we were struggling with resolving some of these offsets, but this is essentially walking the export table for a given DLL. And then this is the starting address for, or no, I think this might be the DLL address. Anyways, it doesn't really matter. This is actually walking the export table. And then this is essentially the hashing function that we were looking at last stream. We didn't really mark this up too much just because we were kind of able to skip that step using hashdb. And basically I used hashdb to resolve these enums here. So if I expand this types menu here, we can see a bunch of different stuff. So this is all resolved using, again, that plugin from OA Labs, hashdb. I can link that in the chat as well. I'm sure if any of you have been doing any type of malware analysis, you've heard of hashdb before, but just in case you haven't. And then the hashdb IDA plugin. I will link that as well. And then there's a Binja plugin as well, which is what I'm using. I'll just link that too because Cindy wrote it. So, so this is Cindy's hashdb implementation for Binja. So that's what I was using. Okay, so having said all that, so there's a few weird things that I had to fix in this database. So maybe I'll open this up again and show you exactly what I did to recover these structures. Because again, like we've seen in previous streams, a lot of this stuff that I've been struggling with is just basically skill issues with me not being great at Binja. So I wanted to show you how I resolved this. So I'll open this with, so we'll say no. So this is just going to analyze this database from scratch. And then I'm going to go to this resolution function here. So again, this is the Havoc payload that we generated using the Havoc framework last stream, just to test and reverse engineer. And again, I kind of wanted to black box this. Hey Wusa, how's it going? In order for us to look at this kind of from a real blue team perspective, where you would acquire one of these payloads, and then you would need to identify what type of red team tooling was being used. So, okay, so here we have, let me just start from the top. So again, we have, this was that first DLL resolution function. So we should be able to use hashdb right off the bat for this. And then I'll show you the weird issue that I had to resolve on my own last stream. Or sorry, that I resolved offline. So if we go to hashdb, so I'm going to hunt on this hash value, which basically means it looks for all the corresponding algorithms to for this hash. Hey Harvest, how's it going? Have you found use for SIGKit so far with malware RE and Binary Ninja? I haven't used SIGKit. I'm guessing that's is that their function identification stuff? I don't think this is libeay, but let's see. Yeah, I don't think that's the right hash. Oh, maybe it is, because it's, oh, okay. I think they're resolving the actual D2IASN1 Boolean. No, I don't think that's right. Yeah, I've been starting to use it successfully recently. Should have used it sooner? Okay, yeah, maybe I should check it out. Let me look that up actually, because I do want to do some signature identification stuff with some more complex languages like Rust. Oh, cool. Okay, so this is like very similar to Flirt, I'm guessing. Python tools for generating, manipulating, viewing, loading. Nice. This is awesome. So that means I could probably generate function signatures for stuff that we've previously written in binary, or sorry, that we reversed in Binary Ninja, and then I could release those. That'd be really cool. Here, I'll put this in the notes. All right, so we'll do red team stream. Oh, we're not in March anymore. Time is just flying. How are the levels, by the way? Are they okay? Signature for. Okay, cool. Thanks, Wusa. Cool. Thanks, guys. All right. For generating signature libraries, that's how I can describe it. Nice. That's awesome. Yeah, maybe we can test that out right after this. Okay, so there's a few things happening here. So again, this is resolving the library, I presume. A4A. But okay, so the issue we ran into last stream is that, so this global is being moved into these local variables, and then the offset in which that local variable is being dereferenced is the resulting, is the result of the hash lookup. So this hash lookup is occurring, and again, we can resolve these using hashdb. So if I do, this is a different hashing algorithm, so I'm going to look this up. And again, we know it's DJB2. And then if I do hash lookup on this, then we see it's loader get procedure address. And then hashdb is awesome, and it lets you import all DLLs. Sorry, it lets you import all hashes for a specified DLL. In this instance, this is NTDLL. So I'm going to click OK. And then I'm going to do a hash lookup on that particular hash. Oh, sorry, wait, I just did that. Now I'm going to do a hash lookup by hitting M, which brings up the enumerations for that particular value. And then we can see this maps to loader get procedure address. And then I can hit select enum, and then it applies that enum to that hash. So again, we just kind of did that to mark this up, so it was a lot more readable. And the issue I was running into, though, was that for each of these assignments and each of these offsets for this global variable that was being moved, and then an offset was being dereferenced to put the hash resolution result into that global struct, this wasn't being repeated, so I couldn't generate a struct of a certain size on the fly using Binge's functionality. So I'll show you how I resolve that. IDA automatically folds all these variables into one, so it's faster. But again, I wanted to kind of figure that out in Binge. So if I right click on this, I can go to merge variables, and then we can actually get a bunch of valid merges here, and we can merge these together. So so these are all RDX. They all start with RDX and RAX here. So say we do the RDX ones just to get the ones that are relevant to that global struct that is effectively the resolved hash table. I can right click on this and then go to merge variable names again, and then just type in RDX, and then I can just select all of these. So I don't know if there's a better way to just select all of these. If anybody knows, let me know, but this is essentially what I did. And you wouldn't always want to do this. Like, for example, if a variable was being repurposed, you wouldn't want to fold these into one another, and you would want that separate variable that's being used for a separate purpose to stay separate, right? But in this instance, we do actually want these merged, so you can do this manually here. Again, we don't have to do that for every single one of these because there's a bunch, but I'll just kind of show you what this looks like. So if I hit merge there, then we can see now all of the variables referenced here are essentially the same. So each movement of this global variable into RDX, then they're essentially the same variable. So this is good, and I'll show you why. Because I can do, what was the, I know it's here somewhere. We essentially want to create a structure from this variable reference. So I can do create structure or just hit S. So I'll just select this and hit S. And then let's just call this resolved hashes. And I'll hit create. And then if we go back to the types menu here, I can go to resolved hashes. And then you can see that this structure has been created called resolved hashes, but there's nothing in it currently. So see how it says resolved hashes packed and then there's no members. I can actually right click, or say we apply the, so this, oh, it is resolved hashes. Yeah, okay, so say apply that structure, then we see this offset, this weird denotion here where it says like offset 138. This is all the high level IL markup that you kind of have to get used to, but basically it's accessing a keyword at this offset. So that's like not super helpful, right? Just because we want to denote that this offset is indeed load or get procedure address. But then if I right click here and go to create all members for structure, then it should do all of this for me. So see, as you can see now, if we go back to, so there's gaps in here just because I didn't finish merging all of those variables, so it couldn't find all of them. But this is essentially the procedure that I did offline, where we get a structure that's created for us, so we don't have to create that manually, which I was trying to do last stream. And then we can mark these up accordingly. So now that we know that this is load or get procedure address thanks to hashdb, I can now mark up these fields with their corresponding resolved function names. So we can say this is load or get procedure address, and then I can say this field is load or get procedure address, right? And then we can say that this global variable is also the same struct. So if I hit T, or no, sorry, not T, if I hit Y, did it already do it? If I hit Y, oh, there we go. Then I can change the type of this global variable, which is the global structure that's referenced throughout the binary and for all resolve functions. And then I can just say this is of type resolved hashes. And I think that should work. Okay. Or wait, no, that should be an address, shouldn't it? Sorry, I just hit Control Z and I did that. So if I do Y, then we can say this is resolved hashes. Okay. And then, so now if I look at the structure, we can see it's a bunch of pointers because it's a function table. And if I go to this offset, then I can see all cross references that load or get procedure address is now called within this Havoc payload, since we've marked that global variable as being the same structure. So essentially going from automated structure creation, thanks to Binja, automated hash recovery, thanks to hashdb, and then our ability to mark up these hashes throughout the sample. So pretty cool. Hopefully that made sense, and I didn't go too quickly, but. So now I already did a bunch of that, and I didn't want to do it all on stream just because it's kind of slow manual work. I looked at automating some of it, but there was some peculiarities with automating these markups. So maybe something I can look at in the future to fix. So, okay. So what I wanted to do this time is see where these functions are used and then see what we can reverse within this malware, or however you want to look at it, red team tooling, this red team payload. So we can do that a few different ways. So we know that this is the hash resolution function. We know that there are still some hashes throughout this function that aren't resolved. So this is likely, so if I look at the hash for this, I bet I can find it. But this is essentially kernel 32, right? So it looks like I marked these up. I did. So I don't know if, so okay, there's two things. I know that Havoc had that option for, hey, hello friends, how's it going? So I know Havoc had that option for either using the Win API or using the proxied syscalls, and we selected Win API. So I don't know if by default it's meant to be used like this boolean effectively. Oh no, that would be the resolved NTDLL function hash. So let's change this. And then resolve DLL. So because we don't really want, anyways, so I'm curious how it decides whether or not to use these NTDLL functions, or it's going to use those anyways. And then the proxy code that we didn't use for the build wasn't in this, but so let's call this kernel 32. And then I just want to see if HashDB will find this one because it couldn't find the other one. We have to change it back to that role hash that we were using earlier. No algorithms found. Okay. But we actually do know this is kernel 32. So let me change that. And our types here. We can use any of these. So let's just use like, sorry, that's the function name. We don't want to change those. We can use any of these, I mean. So let's just edit this real quick. For readability, and I'll just put out the start. And you saw Docker stuff popping up. I'll show you kind of the Docker setup I made for Sliver afterwards. So let's just do kernel 32. And then we'll just use this value here. Okay. And then I'll just mark this as kernel 32 for readability. Okay. Because that might be important later. And I should probably actually mark that offset up here as well. Instead of resolved func, we want NTDLL. All right. Okay, so there are some other resolution functions that we should probably fix. So like if we go to our global function table here, let's see here, sorry. I should probably rename that so it's not as hard to resolve. There should be some unresolved functions here that are assigned. We'll probably see them throughout the analysis, so let's just go back here. So some interesting, so usually what I do once I've resolved a hash table is look at, okay, yeah, so hold on, before I go into that. So I just wanted to show you kind of how we can resolve this. So, or how we know that there's other functions that haven't been resolved yet. So here we can see that we have our function table global variable here, and then we have this offset field 780, for example. And then obviously because it's called field 780, we know this field was automatically generated by Binja, but it was not resolved in our previous function because we didn't mark it up. So if I click on this field 780 and then go to that offset, where we can see that a assignment is being made. So in this sub 1400124D0, then we can see that there's another hash resolution function here. So I'm just going to mark this up real quick because we want all of our functions to be resolved. So another thing, again, it's pretty easy to see because of the high level intermediate language, is we have a few bytes that are being resolved here. So if I highlight this byte like 57 and hit R to change it into a character, then we can see that this is just a regular stack string, right? So pretty straightforward. So it's WSL32.dll. So we could say this is probably, is it W? I can't remember the actual DLL name. W32SL? WSL32? I'll look it up. But I'm just gonna pull my browser here. I think it's WSL. WS32.dll. Okay. WS32DLL. Yeah, that looks right. Okay. And then, so these are going to be WS32.dll functions. So if I look this up, again, HashDB, we're going to have to change back to our old algorithm. So I'll just use hunt for that. And go back to GBA2. And let's mark these up. We'll first have to look them up. Okay, WSA startup, cool. Oh, it's WS22_3.dll, okay. Why do they have to have these weird naming conventions? Microsoft, I guess. Okay. And then we'll call this stack string resolve DLL. And then we'll do WSA startup, and we'll mark that in our global function table. Sorry, I know this is boring because I'm just literally applying enums and stuff, but this will get more exciting once we mark all this stuff up, I promise. So these are important. These are actually important functions to resolve because these are related to command and control, right? So if we want to figure out how they're storing the command and control address or the command and control IP, then we want to know where these functions are used. So we could probably jump straight to the C2 functionality after this, once I've resolved these. Okay. And again, we kind of just want to do this because the more we mark things up, the easier we're able to read this, and then the faster we can reverse it. And thank God for HashDB, because otherwise this would be a pain. And if you guys have any questions about anything else, just let me know while I do this. I could probably do both things at once. So we have connect, GM, good morning, how are you? Big dumb babe. Okay, almost done. All right, look at that. Cool, and then there's probably some boolean to say that it resolved all the hashes correctly. So let's say resolved WS232 funcs. Success or something. Okay. And we'll call this function So are all these resolution functions? Oh man. Sorry guys, this might get, I should have done more before stream. I really tried to get them all automated, I promise, but, so yeah, I just, like, basically I just looked at, so it looks like this is a function table here with all the hash resolution functions. All right, let's just grind some of these out. Or, okay, maybe we'll look at the C2 functionality and see if we can, what we can glean without resolving every single function dynamically. So, okay, so let's look at, for example, so let's look at the socket setup stuff. So since we've resolved that, now we can look at where this is used, hopefully. Okay, so it looks like this is probably related. So if we have, okay, I'm probably gonna need to look up the members for this, but we have WSA socket A. Okay, I see, like there's other stuff that we should probably resolve here, but maybe we can do it on the fly. So I'm not sitting here just marking up tables for hours. So let's look at where this is resolved. This particular offset looks like it's used very often. There should be an assignment location. Here we go. Let's see, field. Let's go back here. Octal socket. Okay, looks like this is also C2 related. WSA get last error. Okay, instead of worrying about that, maybe we should just jump to right where socket is called. Let's see that. Or bind. So I guess you can probably do a bunch of different types of C2 communications. You could probably do a bind port, or you can do a reverse connection, which most people are probably going to do reverse connections. Again, that's just kind of conjecture because I haven't looked at the source. Okay, I want to see where this is used though. Table struct. Here we go. So I know connect uses a structure that we probably want to, the structure is going to contain the C2 IP. So I should probably also make sure that the C2 isn't just in plain text, but I assume it's not. But we can use the strings here. There's like 172 something. Yeah. Oh man, it's just in plain text. That's boring. Well, should we keep reversing stuff? Probably, right? So it looks like this is the config probably. And then it's probably good that I checked that. And then this 14000F940 function is parsing this Havoc C2 config. So what I kind of wanted to do is, yeah, that's not very difficult at all, is it? It's interesting that they put so much effort into protecting the function resolution stuff, but they didn't protect the configuration. Can you mark the config and the C2 as a string? Yeah, I was actually gonna make it a structure. I kind of wanted to reverse like the entire structure, but yeah, I can do that for now. So type, and then we need to make the, I just need the size. So this is gonna be 218 bytes. I think it was already. Oh, okay. So this is the length. So hold on, I just want to mark this up before I forget. So we have the, yeah, and then we'll do, go back to what I was doing, which was creating we'll just create an array of 218 bytes for now, and then we'll mark this up to each respective offset in the structure. Because I bet they're using structured offsets within this config parsing function. So if I do, it was 218 hex, right? Okay, and then, let's see. Okay, so this is making a local allocation, I think, so it's probably going to be this S thing. Let's see. So, looks like it's copying the first 64 bytes here. Display as. I need to set up a hotkey for this because I have it on IDA, but not here. So 64 byte allocation, and then we're copying up to n bytes, which is the config length. What? Is that right? Config length. I'm assuming that's up to 64 bytes. And then the argument is going to be the structure here. So we have the first piece of this structure is going to be the config. So I might as well create a struct of this size. Oh no, this offset is the config length. So n, harvest, is that an unprotected mem copy? I don't think it is, but it's probably just the markup. Because this is an intrinsic. Or, yeah, an unprotected mem copy. So this is going to be, let's see, can we make this a struct? Let's just call it config. Non-embedded Windows stuff. Okay. Okay, yeah, that already looks better. And then if I say, isn't it better when you know how to use the tools that you're using? Where's the type menu? Config. Create all members. Right? Yeah. I don't know why it copies the config length twice into the structure, but then REX is the 64 memalloc for the, let's see, what was that again? Let's go back to the actual config. I might undo this string because it's kind of hard to read. Let's just change that for now. But I'm going to keep it for later. Okay, so let's do that. What if I just make it, making it a chart was a terrible idea. Void pointer, I think it was before. So it'll be 64 bytes, 40 hex 40. The hell? Doesn't make any sense. Because it's cutting off notepad.exe. Okay, let's just call this. Oh, look, no, it's me, I'm screwing this up. Looks like the built-in mem copy is used when the length is no compile time. Oh, okay, cool. No, this 64, I just screwed up the local alloc. I should have looked up the parameters because I'm pretty sure the first parameter is something else other than the length. Oops, I was trying to make it bigger. I made it way too big. Yeah, they're flags. So it's just zero initialization flag. That makes more sense. What was it? LM underscore. Maybe this type isn't loaded. Doesn't really matter. Okay, so so this is copying the entire. Okay, well, so we'll just call this config allocation and the structure, and then oh wait, we want the actual. So this is the pointer config location, or let's say config pointer. Hey Tushy, you can go away. Cool. Thanks, Harvest. Here, I'll also make friends a mod. All right. Let's continue. Man, the Twitch UI is like really hard to use. Like, I'm literally a technical person for my job and I can't even figure out how to ban somebody. All right. Let's, all right, so we have a memory allocation. So this is going to be the pointer to the config. And then let's just call this config info struct. Then we have the lengths. I don't know why it's copied twice. And then we have the config pointer here as well. Yeah, I think Twitch is for Zoomers. No offense against Zoomers. I think you are all going to run the world a lot better than the millennials. Okay, let's do create. Create config. Config struct. Bam, 2 mods in a row. Lusa, I can make you one too if you want. You've been here a bunch of times now. Pray for the children. Yeah. Here, I'll sorry, I'm gonna do one more mod. There you go, Wusa. No problem. I don't know, anybody who's active, I feel like I appreciate you being here. So all right, so create structure, so config info structure, and then we can make this our config info struct. Is that what it's called? Or it's just called config? Like that. And then this is passed. Okay, it's just being passed to this other stuff. So this is going to be our config. And then we have some other offsets that are accessed here that are not initialized. Oh yeah, so the other thing that's super cool is, say I have this like uninitialized struct member, then I can just hit S and then Binge will automatically create it. So I don't know what this conditional is for. Or is this just making sure it was initialized properly? I think so. It's called like everywhere though, so I feel like that's wrong. Let me go back to that initialization function to make sure I didn't read it wrong. Okay, so local alloc. Then I'll just double verify that the local alloc results in a pointer. Yeah. Yeah, I think they even say that on the Havoc GitHub. Like, Havoc, yeah, the Havoc framework hasn't been developed to be evasive. Rather, it has been designed to be as malleable and modular as possible, giving the operator the capability to add custom features or modules that evades their target detection systems. So I don't think it's actually built in. But yeah, I think it'd be very detectable, which we can test out, which I might do later with UnpackMe's Yara search stuff. Okay, so I was just double checking local alloc. So the return value is a declaration spec allocator. What? What is that? Oh, it's a handle. Okay. A handle to the newly allocated memory object. Okay. So this is actually a handle. But if it just does a built-in mem copy, then maybe that's different. All right, maybe just let's stop worrying about this so much. And I just don't know why this is called so much. Unc field. Let's just call this condition. Config length, config parameter, or config pointer, byte swap. Okay, so let's just say config pointer encode maybe. We can probably check that dynamically. Maybe I'll do that later. RAX. I don't think that's it because it's actually getting this, which is the config pointer, apparently. So maybe I'm... Sorry, this is annoying. Okay, handle. Oh shit, sorry, I missed a bunch of chat. Lil Brayan. I have an associate in science in cybersecurity, but no experience. How can look for jobs in malware analysis and RE? I'm 25, so I feel like I am getting old. No, I started my RE position, or like malware research related position. How old was I? Like an actual researcher role, I think I was like 27. I think 30. No, I was younger than that. I think I was like 20. I think I was around your age, so it's not. Yeah, 25 is super young. I know people who like were not getting into security until their 30s. So, but in terms of how you can get a role in the industry, honestly, becoming involved in communities like ours is a huge networking opportunity. You have a lot of people like myself and others who are on these streams and in the OA Labs Discord and in our Discord who are involved in the industry already. So having contacts like that is super important. Doing malware reverse engineering and then posting blogs, which a lot of our students have been doing as well, is super important. If you can, I know it's difficult outside of work hours to do it if you're busy and stuff, but that's probably the best foot in the door at most places. If you can apply for internships, I would suggest doing that as well. The fact that you have an associate in science and cybersecurity, I'm not entirely sure what that means, but like an associate degree, I guess. That's already a really good starting place. But again, getting your foot in the door somewhere, if you could take like a junior SOC position or anything that'll get your foot in the door, I think that's also a good starting place. I started in quality assurance, which is kind of a weird place, but I was doing QA for a malware kind of early EDR product, and then I moved into malware analysis. So, and I highly suggest doing as much programming as possible. So we're not doing a ton of programming on this stream, and I'm still not a very good programmer, but knowing how things work and how code works under the hood is super important. So Speaking of which, let's figure out how this code works. So this is a handle. Maybe this isn't the actual kernel 32 local alloc. Let's see where this is. No, it looks like it is. All right, so let's just assume that this is accessing the config offsets. So let's go back here. Yeah, the more curious you are, for sure. And don't be scared of AI. AI's been so overhyped, in my opinion. I could be eating my words in a couple years, but don't worry about it. Just work on cool stuff and you'll do fine. Yeah, no problem. All right, so let's see here. What are these structures doing? Let's see. Or what are these functions doing? Some more function resolution. Wait on single object. Wait for a single object, I mean. See what I mean about marking up these offsets, how important it is? Because, like, create thread fiber. Oh man, there's a lot to this. So I think this is all multi-threading related because it's RTL register wait, like this is all threading stuff. Virtual protect though, that could be interesting. And to get thread context, RTL. Okay, we could probably go back to the config stuff and just say this is thread related for now. So I just want to see what these are. Looks like more struct setup stuff. So whenever I'm like going through stuff and I'm just trying to get a lay of the land, I'll usually mark up function names with what I kind of think a function does and then just put question marks at the end. Just to give an indication that I was there before. So, okay, let's see if we can resolve what this dynamically resolved function is. Which is here, or here. Interesting. So maybe they're using this global for more than function calls, but wasn't this actually... Oh no, it doesn't look like it's actually being called. So maybe we should rename this to just like global info or something. Global funcs and config or and data. Because this is being accessed where? Okay, no, maybe this is a dynamically resolved function actually. This is being here. Okay, let's just go back. I keep getting distracted because it's comparing it to, okay, let's mark this up. Maybe this is probably a kill switch. Let's just say time kill switch. So the reason I say that is because there's this function called get system time as file time. And that's, let's look that up. And what might be fun afterwards is once we've reversed a lot of this, we can probably go look at the source code and see how right I was. File time structure. Okay, so let's, hopefully this type is loaded. All right, so this is the load date time. And we can also set this type to file time. And then just say this returns file time, and that already did that for us, so. Yeah, it can definitely be used as a timestamp for exfil. I just wonder why. So see how it's doing a comparison that if it's an unsigned greater or equal to this global time thing, then it's exiting the user thread. That's kind of all I was thinking. Yeah. exit time or something. But this might just be threading related to. I don't really know how their thread model works. I should probably figure out what this actually does. Byte swap. Config. I guess might be getting config offsets. Would that make sense? Config length is greater than 3. Might get some more eyes on stream as software dev. Oh yeah. Yeah, that's a good shout. Can I change the category while I'm on stream? I don't think so. Yeah, I don't think so. Oh, yeah, I can. Software dev. Software and game development. Cool. I figured it out, you guys. The boomer figured it out. All right. What's this argument being used for though? Okay, so it's not always the config, so I should change this because it's basically just accessing some length, and then it's making sure it's greater than 3. Data. Oops. So I should reset this type too. So it's accessing the, because if I go back here, this isn't always the, maybe it is passing the config around. arg1, arg1. Oh yeah, maybe it's just passing it as an argument. All right, maybe I'll fix that then. All right, let's just keep going. I'm getting too fixated on these small things. All right. Again, a bunch of struct offsets being accessed here. Okay. So this is called after. Yeah, that makes sense. All right. So this is the first. This is also 32 bytes. And then that 32 byte allocation. I just don't know what this is doing. Data. Oh, Docker really wants to make connections. Well, let's see if I can. Maybe the high-level IO is confusing me. Then the data's from the first pointer to the second pointer, and then it does a byte swap. And then this is the first byte. I don't know. But I think this is important because I think it's helping parse the struct, the config struct. Local alloc for n bytes. I'm just gonna make this a structure as well. All right, sorry, let me try that again. All right, so we have the config struct being passed into here as well. So we don't want to make that a new structure. All right, config length. Okay, this is very similar to the other function. Can you ask on AI? Yeah, I can. Let's see here. I think it's just gonna be like, it's accessing these config offsets because I set the structure. Maybe I should undo it. Processing, configuration, or data structure. Updates. See, it's going off of what I wrote. The new value is calculated by subtracting 4 from R8. Yeah, like this is just calculating a pointer to a specific data. Part of a data buffer. Execute additional code that is not shown here. I don't think so. Function seems to be involved in parsing or setting up. Okay, what if I get rid of this configuration stuff? Okay, now let's get it to do it again. Data structure manipulation and conditional checks. Retrieves a pointer. Dereferences the pointer. 32-bit. Yeah, it's just kind of explaining the assembly, so, or the decompilation, so it's not super helpful. Complex data structure, various fields. Range of initializing data, blah, blah, blah. All right, I'm gonna continue with what I was doing. It might just be incrementing the current config location, and it like walks the config bytes. Same with the other one. See, because it's getting the next. These are keywords, right? So, or no, these are 32-bit. Maybe it's only thinking it's 32-bit. No, it's definitely keywords. So that's what I think. And then if this length isn't greater than 4 bytes that it's incrementing by, then it returns a null pointer. So it's gone to the end of the config, right? So what that tells me is it's probably a variable length configuration that they need to walk in increments in order to get each field, I believe. I don't know. Maybe this is just like a crazy way to program this, but that's kind of my guess here. Is that this is a variable length configuration. And then this one's doing the same. See, if config length. So maybe we should rename these struct members. So current offset, and then this walks backwards. Oh no, it's still the same. Data is doing a byte swap. Where in high level IL, still a byte swap. A byte swap of the current data location with, what does bswap do? So does these functions return a value in which the order of the bytes in their 2 minus 4 minus or 8 byte arguments is reversed? Okay. So it's doing order reversal. I don't know why it's doing that, but then we probably have global structures as well, because this one's not doing a byte swap. So yeah, the address of config pointer 1. I think that's right. All right, so let's go back to the top here. This one's, I want to get back to that original parsing function that we were in. All right, yeah. So I'm guessing these are stored on disk. Like these are integers that are stored on disk in a different byte order, I presume. And then these are getting moved into these offsets. So that's why this looks so weird. It's because the config pointer, the configuration blob is effectively being walked. Yeah, that's what I'm suspecting. Inspector diameter is that's effectively what's occurring here. And then these fields are being populated. So what we can do to make this a little bit faster is we can open up this in a separate. Is that going to take up too much real estate? Let's see. Can I want to make one of these panes the hex dump for the config. Yeah, let's just do that. Or maybe on the other side because we're not really using the disassembly that much. So on the left we'll have our hex dump, and then here we'll have the Havoc config. Oh god, these are all synced. Hold on. Okay, so we have, so these booleans obviously mean something. We have probably the length of the string here. This 64 bytes, possibly, but we can confirm that, right? But so far we know, based on like the plain text parameters, we have, yeah, I know, it's weird. Or this could, oh, maybe those functions, those weird functions are UTF related. And I just don't know how to read that code. That's a very good point, actually. Like the other set, or the other kind that I was looking at, this one. Not the walk, but the other one. Hold on, let me get back to, watch us look at the source code later, and I'm just gonna be like, oh, it was just that. But that's okay. It's part of the learning opportunity. So this is our configuration, and we have the first field, which is, I believe that's just going to be a boolean. So we'll just call it like uncbool. And then the next set of 4 bytes, which is also going to be an unknown boolean because we're not entirely sure what it's used for yet, but we can reverse the code for that. This next one is, again, 40 hex bytes for who knows what. We'll just call it unc length. I just called these a booleans because they're 0, 1. So they're just these. And then we have, let's see, we can pull up our structure here on the side as well. Oh, not that one. I wanted this one. So we need more windows. Because if I go to this, or if I go to this, I want to be able to jump to that offset in our global structure here as it's assigned, but I don't know a good way to do that. And then we have, because field 100 offset FC. Oh, cool. Okay. FC FF 100, right? So is FC plus 4? Oh no, that's way more than. Sorry, my hex arithmetic is bad. Yeah, that's what I thought. Okay, so this is just 4 bytes after. So this is the 43. Okay, so this is the start of our string, right? So is this 64 bytes? I think it's more. Because 64 goes up to, let's see, 40. Oh no. Okay, cool. So this is notepad.exe. So this is our injection target. Right? What malware are you even reversing? Hey, Rookrock. Yeah, so this is just the Havoc framework. So this is like an open source C2 framework thing. So this thing, I'll send you a link. All right, so let's keep going. So then, so I don't really know if this is actually reversing the byte order anymore, because let's just say it's malware walk config bytes, and then we'll just say it's like a different style of it. Okay. And then we have the, let's see. Oh yeah, and then, all right, this will be the injection target length. And oh, the reason I know this is an injection target is because we set that in the last stream. So we set it to notepad.exe as the injection target to inject into once the payload runs. So then the next thing, okay, so we should probably make this, we should probably make this a separate structure, right? So let's say, oh, I can't make a structure from here. Oh, I can, cool. Can I do this? Oh no, that made a substruct. We don't want that. What just happened? Okay, and then we actually don't want this to be a field. Let's call this config struct. Maybe we'll do config blob because I want that to be different than that config walking thing that this function set up earlier, right? Config info struct, I want this to be different names. So then if I double click on this, or maybe not double click, but I just want to edit this struct. Config blob, and then we'll just do, okay, undefined type, and then we'll do, there's got to be a faster way to do this, right? Oh, I guess the first, did I mess that up? The first value is a 2. So this isn't really a bool, it's probably like a flag or something. Unc flag. And then this is a bool. And then is this, how big is this? So this is offset 60, offset 64. Okay, so it's only 4 bytes. So 1, 2, 3, 4. I should be able to just, let's see. So is this all encompassing? Sorry guys, I'm just trying to get used to the Binge UI. Whatever. Let's just say these. I wonder what will happen if I do that. Whatever. Set structure size. Yeah, I just created the same little field there, so we don't want that. All right, there we go. Okay, so yeah, again, just me getting used to the UI stuff, skill issues. If I hit D, then I can create an integer, so an 8-bit integer, 16-bit, 32-bit, right? And then I'll mark these up with our markups that we did earlier, right? And then this is going to be, okay, so let's do, this is going to be the unc flag, unc bool, the injection target length. Oh, did I screw this up? Oh, right, because it's going to be not referenced. Yeah, okay. It's not referenced in order. It should be referenced in order, though, because this is going to be the injection target length. So I'll just say unc bool, unc flag, unc flag, unc bool. And this will be the injection target length. I'll say inj target length. And then this will be a character array of, sorry, I keep getting confused because the integer ends, or the string ends early. So A. No, that just made it into single characters. So I'm just trying to figure out how to make this a, this particular offset a 64 byte ASCII array. I don't think I can do that from the actual UI, can I? Oh shit, I don't. Oh my god, I just want to change the struct member. Change type here. There we go. Okay. And then again, we have the same thing. So we have inch target. I don't know why it's repeated, but inch target length. And then we have the again, this is 64 bytes. So we want that. As crap. Sorry. All right. Yeah, how did I already know that? All right. And then we'll call this inch target 2. And then there's a bunch of padding. And then we have the, so it's going to be using HTTP for C2, I presume. And be using a post request. So let's go back to our actual code here. So this is going to be, we want this to be our config structure that we just created, right? So config blob. What just happened? If it's a cast, can I not change the cast? I have to be able to. There we go. Why is it doing that? That's so weird. So like, is this not a local variable? It has to be. Alright, yeah, that was a bad idea. Okay, but we know this is going to be the zero offset. Maybe not. All right, let's keep going down these walk config byte calls because this is going to be walking our structure, right? But this local alloc should be the, let's just call this injection target. The first one, I presume. I tried to reanalyze it. Reanalyze which one? Or what area? Top left of the function area. Oh, like hit reanalyze here. Top left. This little squiggly. Cool, nice. Yeah, I don't think it did much, but it's good to know that that exists. So, okay, so this length is going to be the, yeah, I agree. It's definitely good to reanalyze the function periodically if you can, or if something's not working that you want. I'm just kind of confused because this, so like what's screwing up my analysis here is like because of this weird walk config bytes thing that's just periodically walking forward 4 bytes it seems. It's hard for me to kind of like keep track in my head what's exactly happening. So we have the unc bool. Like I could do this dynamically and it'd probably be faster, but I kind of like doing it statically so I can become better at it. So we have the unc bool, or the unc flag rather, bool. I don't think this would be the injection target length. Let me set that. What? Why did it disappear? Unc. This would be unc flag, unc bool. Or these could just be placeholders, right? They don't have to be booleans just because it's the value of 1. But we have unc flag, unc bool, unc bool, unc bool. Then we have the injection target length. Then we have this pointer that's being allocated here. Then we have the, so this is going to be the injection target. And then it's doing a mem copy into there. See, things are coming together now. And then we have, this is going to be the second injection target. I don't know why it does it twice. Ugh. Okay, so hold on, it's just hard for me to visualize this. Maybe I'll add comments. Because at this point we're at the injection target string location in our walk config bytes thingy. So this is going to be another injection target length, or well, this is going to be the actual buffer. And then we'll just do injection target. Inj targ2. Okay. All right, let's then this is going to be, so the other thing I'm not entirely sure about is whether this is going to be this padding, right? Or if it's going to be this post request. I guess we can see where this is referenced. But maybe just to make sure that my injection target stuff is right, we can look at where this is being used in the program. So let's do the first injection target and then see where that's used. It looks like it's used here in this function. Okay, let's check this one out. So this looks like just a string offset thing. Not string offset rather, but length. Because it's just doing a while loop, and while it's not equal to null, then it's just copying over the address. Sorry, not copying over the address, it's incrementing the address because it's getting the address of RAX1. So this is kind of just a interesting byproduct of their decompilation. Memset 0. Oh, it looks like this is cleaning it up. All right, so hard to tell if that's actually correct. What about the second one? That's a walk config bytes thing is used like everywhere. Is this the same function that we just looked at? Okay, this case statement is probably important. So let me get back to that actual address. Okay, so global function inj targets, if it's not null, so length, but it's mem setting it, so that would zero out the injection target here. So yeah, I think this is just cleaning up the pointers. So then it walks it again and then mem copies it. Weird. So let's look at where else this is used. Maybe there's a another injection function. Like maybe this is overriding the injection target. So I'm going to mark that up. Again, unless, I don't think I'm wrong, but because those 64 bytes match the injection target length that the mem copy is being made for, so I'm pretty sure that struct member is correct. So So let's see where else this is used. As I mentioned, what other functions? Okay, so, okay. So I think this is probably our injection code. So let me get, so it's doing a create process here. So we have our, yeah, perfect. So let's see what this function is that I didn't resolve because I didn't want you guys to sit through it. So this is the MW create process with token. Create process with token W, I mean. So this will be, and then if we go back here, yeah, so we're on the right track with our structs. MW create injection target process. So that's good news. How's everybody doing? Is this okay? I know reversing structs is kind of tedious, but it's very necessary. So I suspect this second walk, like if this walks up to the, no, I think it's just incrementing 4 bytes. So maybe we can just do the, you're debugging? What are you debugging? Embedded stuff. Mitigation bypass. Ooh, sick. Nice. Yeah, I want to do more Vuln stuff, but maybe I'll pick some easy targets and then work on those so I can get some wins instead of like super hard stuff. Okay, so we have the injection target 2 here, and then this is going to be those padding bytes, right? So these guys, oops. So it'll be, let's just call this null. Byte padding. I'm just gonna call it padding, even though it might not be padding. It's kind of a pain in the ass marking up the global struct, because the global struct is, I guess I could assign the struct offset. Like, so the global struct is what I created with Binja and the giant function resolution stuff. So like each of these fields are effectively a structure within a structure, which is like the second structure that we're assigning. We should have a counter for the name, for the amount of times I'm going to say the name structure in this stream, but basically I'm defining 2 structures kind of in line because this global structure is this function table thing. So this isn't like 100% correct, but I think we could probably fix them later to have a structure within a structure, have these different function tables instead of just having one giant table of pointers, but this is okay for now. Soho routers could be a good place to start. Very cheap exploits / less demand. Cool. Fine one with UART. Yeah, so I did a little bit of that with like a local ISP extender. My buddy and I were looking at it a long time ago, and it was just like string copy. Like the only thing that was saving them from having a classic buffer overflow was just the stack canaries. Like if the stack canaries weren't enabled, you could literally do like the frac article from the 80s of jumping straight to your shellcode on the stack. So yeah, I know the Soho stuff is kind of a disaster, but yeah, that's a good idea. I know, like I really like Gamozo. I'll just link him right now. He doesn't really do that many streams anymore, but He's super awesome. So you would, like, in order to add the canary to the payload, you would have to leak it first, right? Yeah, Gamozo does exploit debt. I don't know, he's just crazy because he has a huge amount of Rust experience and stuff. He also has a YouTube. I think it's Gamozo Labs. Yeah, this thing. But he has like a ton of, oh, he's doing some CNC stuff in his garage, I think. But yeah, so 4 months ago, so he's still doing stuff. But yeah, he's super awesome. It just reminded me of the Vuln stuff because there's like a printer hacking series he did that was super good. I'll see if I can find it. But yeah, I feel like doing live exploit dev would be cool. Maybe on like CTF stuff, not like real targets. Okay, so all right, I got distracted. Let me do these null bytes. Man, this is super ghetto. Like, why walk this like this? I don't get it. Maybe the C code will make more sense. Okay, so then we have, like, I'm assuming this is the length, HTTP method length, because there's padding, char, a. Okay. So 2 null bytes, just because it's, I guess we can make this, we should probably make these the correct character type, right? What would that be on Windows? W chars? Oh wait, shit. We want to keep the same length. Why is it doing that? Inch target. And then we want to make these W chars. I've been considering streaming a Privesc for the Pixel 8 via GPU driver. Could use an older version to write or extend exploit POC. Yeah, exactly. Yeah, so there's like a ton of stuff you could do live. That'd be super cool. Yeah. Do you like Gamozo? Big dumb. Yeah. I think he's awesome. I just leave his stream because he has like 8-hour streams, so I just like leave them on while I'm working and stuff. It's really nice. All right. Keep getting distracted. Let's do W char. Inch target. There you go. Look how nice that is now. I guess it's not. It's bigger than 64 bytes. Hold on. Why can't I edit this directly? Oh, did it change the? See, it's weird how maybe W char is different size. Whatever. I'm just gonna leave these for now. Because when I make them chars, then it has all of them, all the bytes, right? Okay, sorry, I'll focus. I can make the structs pretty later. All right, so then we have the HTTP methods. So let's see. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So let's get to the 18th call. This is so ghetto, dude. Like there's definitely, like these struct members are definitely for something. So I should probably figure out what those are too. But man, it's brutal. Like these are probably config parameters that are not initialized. wchar utf16. Yeah, I think it's something to do with the encoding, but we don't have to worry about it for now. Just as long as we have these, like the struct aligned properly. All right, and then we have the IP. So like, should I try and figure out what these 0 struct members are, or just move to the C2 stuff? At least the config isn't crazy. All right, let's look at the... So let's, I think we could probably automate some of this too, like just counting the calls to this walk function. So if we do like, say we do for, so current function, HLIL. So if we do like current for instructions in current function HLIL instructions, and then if instruction is it instruction.name? Name? Why isn't it showing me the current? Why are you working? Okay, whatever. Let's just do that for loop. I just want to match all calls to this MW walk config bytes thing. So if I do like instruction dot BNIL graph could help. Yeah, what's that plugin again? Is it just called BNIL graph? Instruction graph, this one? Install. If you want all calls, I would get a function pointer to it. Yeah. I just want them, the ones that are in this function though, not all of them, if that makes sense. But I guess I could just say, that's probably a better way actually, what you just said. Okay, how do I use it? Yeah, view. Is it one of the views, or is it over here now? There's all this sidekick stuff now. Here, I'll just read the description. So manual installation, I already did that. Okay, right click. Okay, and select BNLI graph. Okay, so right click BNIL graph somewhere. Right click on an instruction, select oh, it's in plugins. Okay. Plugins. Why is it not here? Do I have to reopen the database? I think it's enabled. Yeah. It's enabled. Okay. Okay, let me save this, because that would suck if we lost this database. And then we don't need this one, but we do need this one. And then let me reopen. Oh, I might just have to reopen it. So it's this one. Yeah, BNIL. Sweet. Python matcher generator? Dude, I didn't know it had that. That's sick. That would have saved me so much time. Okay, let me try this. Yo, this is sweet. How for vectors should, oh, yeah. Yeah, I also took the Paver course. By the way, speaking of the Paver course, I'm sure some of you heard, but let's see if I can find it. Sorry, just need to grab my Twitter. So I took the PAVR course a number of years ago, and it was taught by, well, it was a Binary Ninja vulnerability analysis course that was taught by Jordan and Sophia. Unfortunately, Sophia passed away this week, so I just thought I'd mention that. Or on April 4th, rather, not this week, but extremely sad. She was 30 years old, super talented researcher. Met her a couple of times at Recon, and yeah, just tragic. So I just thought I'd mention that. Yeah, Sophia was extremely kind, so really, really bummed out. And yeah, heart goes out to all of her friends and family, Jordan and everybody who knew her super well. So very sad. Oh, cool. I didn't know that. Or well, I didn't know they would offer classes for that reason, but that's super cool. Yeah, it was really good. I enjoyed it. That's actually what got me like kind of on the Binja train, was that course. So so it doesn't give the matches in high level IL. But I'll look at this code, because this BNIL matching stuff is exactly what I want to do, like offhand. So all right, let's take a look at this. So oh yeah, so they don't have it in the high level IL. I guess we don't need the high level IL, we just need the function. Constant set, let's see here. Was I selecting the wrong instruction? Probably. Call to. All right, so let's just do the all calls to this particular function. I think it will do. So let's just do for func in, I can't remember what the API is. I'll just ask the AI. All calls. But yeah, the plugin's sweet. Like if I do, I just don't want to get, because like I'll have to recursively walk each of these, because they're different forms. What? It's called. No, I want you to give me the code for it. Oops. Yeah, sorry, I just need this to help me count stuff, because otherwise it's gonna be very slow going. Okay, so now we can do, oh, get function by name. That would have been faster. Let's do a snippet. And then we'll do get func ref count or something. And then we'll do callers, get callers to that start of that function. Yeah, this looks good. If we look at the log here, did you mean get functions by name? Is it the callees? Is that why? Is the address of the functions that call it? Oh yeah, that could be right. Yeah. Get call. How do I get the call locations to a specific address and to a specific function. And that's why I thought it might have been calls. Let's see. No, that should be right. Oh, no way. So it's because 7330. Why would it? Okay, so at the end of this function, see this curly brace? Okay, so see this curly brace? I feel like I wasn't, like it obviously was my mistake, but this curly brace, because it's the end of the function, it's the function start address. So this is definitely like a UI thing that, you see what I mean? Whatever. Sorry, guys. Brutal. All right. So now we want yeah, Pigetrol for sure. All right. So now we want just trying to think. So now we want, so let's map each of these to the struct location that it's like bringing forward. So we have, so say we want this struct offset, right? Then we want to get the 1, 2, 3, 4, 5, 6, 7, 8, 9th offset of this. So let's pack these into an array so I can just reference the array afterward. Just do locations. And then we'll do struct append caller.address. Okay. And then let's just print that out after. Target function is not defined. Because I did that. And I should have just left the code the way it was, but of course it was bugging me. And this if statement is also gone. All right. And then if we get the offset we want, so what did I say earlier? 1/9. Then that'll be offset 8 in the array. So we want a 8. So the 8th call location of this increment function thingy. So this is the location. Wait, that didn't work. 74A. There we go, that worked. This, we want to go back to our structure. This thing. Oh my god, please. Please stop being so difficult. There we go. Too much shit open in the UI. Alright, there we go. So let's go there again. I like the pains, but sometimes they are a PAIN. Like my pun. Alright, so this is going to be the first null offset. So this is initialized to something. Just to those null bytes. And then we have the 9th, right? I'll often float the plane. Yeah, I was thinking of doing that too. Just because It is a pain, but I kind of want everything. Like, this is a pretty big screen. You guys probably can't tell, but this is like a 25-inch screen, so. Does it make sense what I'm doing, by the way? This is like just some 80K. Basically, I was sick of looking at what offset we're currently at for a D-word struct member. Of course, this pane went back again. So we have null bytes 4, and then we have our $80K. So, okay, this is kind of weird too. So the runtime struct is different than the config struct. Ugh, this is annoying. Do you know what I'm saying? Because like this 80K thing isn't from the structure, it's just initialized at runtime. So I guess I'll leave that out. So let's see what this config bytes. Oh god, it's another one. Is this the same code? Is this doing the same thing? Oh no, it's incrementing by 8. Or is that what the other one was doing? The byte swap. Man, this is a pain in the ass. Oh, I think it's just because it's getting an integer. Because this is the kill switch thingy that I was talking about. Let's see if I'm actually right, if that actually exists in Havoc. I don't know what they call it though. So I don't know. Sleep. It might be a sleep. But it was exiting, so indirect. Syscall. I called it a proxied syscall, but it's actually, they call it an indirect syscall. Okay, so there's a spawn 64 process and then there's a spawn 32 process. So that's the difference between the ones that are reversed. So if we go back to our little config here, we have, you can't really tell, but this one, which is horrible to read. One of these is 64-bit and one of these is 32-bit. So that's why there's two notepads. Yeah, this is syswow 64, so this is the 64-bit target. So that makes sense. And this might be the sleep. Is there actually not a? I like how there's multiple sleep techniques. That's cool. Check-in. Maybe it was the check-in period. These are commands though, so. Why would it be exiting the thread though? All right, whatever. Let's keep going. Oh, right, so I can mark this up. So this is gonna be, oh, it's how you found it, friends. Hell yeah. Yeah. Do you like my RE skills? So I call this kill date, is it? And this is kill date, which looks like it's 0 by default. Okay, and then we have, so that thing I just wrote doesn't really work anymore because there's different types of walking functions for different data types. Whatever. I think we're still on track here. So so then we have null bytes 4, or null bytes 5 rather. And we can, again, reverse those to see what they are, what they're being used for. But it's handy to know that. And we have another mem copy. So this might be the post request length, which would mean we're at the like this is incorrect. So if I do, I should be able to look at the struct here, right? So config function table, we have injection target. Yeah, so the runtime structure is quite different than the load time structure. That's okay. Let's just keep going. So I think this is where is that alloc that I was just looking at? So we have null bytes again. Then we have the post, or wait, HTTP method length. And then the HTTP method. And then the source address is this thing. So we have RTL allocate heap. I don't really know why they have local alloc and then they're also using RTL allocate heap, but it looks like this structure might be a little bit different. Jump REX. That's okay. And we can check this with dynamic analysis too. We don't have to keep it at face value. But we can check, actually, well, we don't have to do that either. We can check the code. So if we do, I bet this is going to be HTTP related. Yeah, I need to resolve these two. So if I go to, where is this initialized? Here. Isn't that a call though? Sorry, hold on. Unless they're doing, okay, built-in mem copy. Yeah. Maybe I will take a look at this dynamically because this is pretty slow going. But this is like, this should be the HTTP method because that's the only thing that's after this. Or that's the only string. And then there's the IP and the user agent. So we're kind of almost done. It's just annoying because I didn't finish marking up all of those functions, so I could probably do that before next stream. But let's just, I'll get the struct done as best I can. Okay, so then after the post method, we have, okay, my guess is that this is copying over the config IP in this for loop. So this is doing an RTL allocate heap of 32 bytes, right? So that's going to be the IP size. Display as, so 32 bytes, right? So it's going to be, sorry, 32 bytes. Sorry, I'm thinking in bits. An IP would be 4 bytes. So MW expand memcopy 32 bytes. Maybe the kill date. Oh, sorry, that's from before. All right, and then this is another one. Shit, there's a lot of more parsing code here, guys. So what do you think? We can either confirm some of these structures using dynamic analysis, we can look at some Sliver stuff. Any preferences? Because I did find some Sliver stuff that was kind of cool. Some Sliver maybe, sure. Before we do that, I'm just gonna run the washroom. Okay. Yeah, like, cause like this stuff is just really slow going, so I'll have all the structures marked up for you guys and the functions for the next red team analysis stream. But yeah, before I do the Sliver stuff, I'm just gonna run to the washroom. So I will be right back. Okay, so I wanted to show you guys what I found with Sliver, because I thought it was pretty interesting, because we were looking at some of the code, like we were kind of black boxing it last stream, where we were looking at we were diffing two binaries, the plain text binary and the obfuscated binary, and we wanted to see if there was any code similarities. So I was really curious what project they were using for their obfuscation. So if I look at their code here, I just want to pull up the stream manager here. And I type in, okay, so I did two things. So I kind of wanted to get like a little dev environment set up for Sliver just in case I wanted to make any code changes. So what I did was I created this Docker file. So I don't know if you all are familiar with Docker, but basically I use Docker to create this little dev environment with this Docker file. And basically all it does is it sets up so this is derived from the normal Sliver Docker file, but this essentially uses a Golang base, updates uses apt-get to update the base Docker container, adds a Sliver user, and then just owns the directories and stuff. So it just basically sets up the environment, and then it adds the Golang code there. So then once this is set up, I think I have an interactive session open in this container right now. Let's see. Should be one of these. Yeah, here. So then I can do like make, and then I don't know what it's downloading right now, but this is basically building the Sliver project. So then like I can make modifications to it. We don't really need to make any mods, but I just wanted to show you what the obfuscation stuff was. So string, I just searched like obfuscation, and then it came up with this symbol obfuscation, and then kind of the same stuff that we looked at last stream. Basically, they're creating a protobuf with the obfuscation flag enabled or disabled, and then what that does is it affects the build process. So if I go to, there should be go.go somewhere. It's in generate probably. So skip symbols. So yeah, there's this symbol obfuscation stuff. And then these eventually get set into a protobuf that's written to disk, and then the protobuf is used during the build process. So if I go to binaries, I think it's here. So yeah, render Sliver code with these go config options. Then does a go build. Sorry, I found this before stream, but Oh yeah, so then I saw this obfuscate symbols flag and then this go garble flag. So I was like, what's go garble? So then I went to, I just searched for go garble. Oops, is that it? Yeah. And as you can see, it says obfuscate go builds. And so this does a whole bunch of different stuff that they're integrating into their build pipeline, and then it obfuscates the final payload. So this was, I think this project's pretty old. I won't go through the entire commit history, but there's like, I don't know if they've been using garble this whole time or if they integrated it recently, but it's produce a binary that works as well as a regular build, but with as little information about the original source code as possible. And then it's coupled with command/go to support modules and build caching, deterministic and reproducible given the same initial code, reversible given the original source code to deobfuscate panic stack traces. So this is the part that I'm really interested in. Oh, really? Sergey already looked at this. Okay. Golang garble. Standalone string decryption. That about a function may not access stack areas above the one that it started at. Yeah. Like within the current frame of the function. Okay, so it looks like Sergey used, like, upon entry, your RSP says, yeah. What about it? Okay, so use unicorn in capstone. I'm trying to see how this works. And then he's providing the bytes to decrypt. Okay, sick. Sorry, my firewall is being super annoying. Because I want to see if I can identify the, like, an example decryption function that Sergey is talking about that I can then emulate. But I should probably try and recover the function names first. Can I just do it in, maybe I'll put this elsewhere because I don't really know why this isn't working. All right, here we go. Okay, sorry about that. Well, this renames everything. Since I'm here, may I ask a short description of what you're trying for? I heard something about obfuscated database. What makes me extra curious is the Clang accesses. The Clang version. So I'm looking at some open source red team frameworks. The first one's called Sliver. So this project, I think there's just, hold on, sorry. I think it's just sliver.sh. And then, yeah, so I'm just looking at this Golang. So I'm just looking at this Golang C2 project. Basically, it produces malware. So I'm looking at obfuscated malware. All right, so it's interesting that it obfuscates these paths and then produces that base64 that I was talking about with garble. But then these function names are still here, which I guess is still kind of a pain, but so usually there's a main, but obviously that was probably garbled. So, okay, so like in some of these, there should be one of those string calls. Maybe it's one of these. You need a coffee letter? Okay, I'm just gonna look at the strings here. Because GoReSim should have created some strings for us too. Yeah. I could go for some more coffee, but I can't drink any more coffee because it's so late. Or else it'll keep me up. Oh, that's cool. You're hanging out on Twitch and you're 44. Nice to meet you, George. I'm Josh. Sorry, I'm just looking for one of the obfuscated string blocks. Like there's a bunch of obfuscated function prototypes, but I was expecting to see something else. Like this. That looks like an obfuscated string. I see. So yeah, okay, so there's a bunch of these. All right, let's see if we can use Sergey's code. I might need to set up Unicorn though. I'll probably just use Docker. All right, since we're like 4 hours in, I might make this a to-do for next stream. So let's, okay, so let's do Havoc C2 IPs in plain text. The configuration parsing code is kind of crazy and may indicate a variable length configuration because integers oh yeah, sorry, not yet. Are these notes BNDB anywhere accessible? So yeah, the notes are going to be on GitHub. The BNDB is, so we have like, I'll show you in a sec, 1 sec. But we have like a premium course membership that gives you access to like all my reversing artifacts, including like these BNDBs and stuff. I hate to paywall them, but we're just trying to find ways to give premium members extra stuff. But yeah, all these notes and stuff will be on GitHub for free. Okay, so the configuration parsing code is kind of crazy. It may indicate a variable length because integers are periodically, or well, let's just say because data is periodically walked with different function calls. To do finish structures, finish Havoc, finish reversing Havoc structures, config structure, I guess. And then we can maybe automate writing like a config extractor or something for more and look for more samples. That's okay, you gotta make, yeah. Okay, and then we found, I don't know, interesting findings, kill date, I don't know, we don't really have to put that actually. Let's just leave that. So let's do, and then we'll do found Sliver's obfuscation mechanism, which is garble, and then found Sergey's deobfuscation technique. I'll probably just put in the the non-archive.org link later, but for now, let's put it in there. Okay. And then, and then another to do is going to be set up emulation code like Sergey and write automation to identify target functions for emulation, something like that. So, and then ideally this leads to the obfuscation of C2 addresses. Okay. So I think we made some good progress today. Thanks for sticking around for so long, guys. It was fun. I'm just going to run a quick ad for our malware reverse engineering course. As always, appreciate the support, and I'll see you all in the Discord. I'll drop the Discord link in here too. Yeah, thanks for joining, Meatball. Yeah, I'll play that ad and then I'll do the outro. So thanks all for joining and hope to see you on the Discord. Take care. Yeah, sounds good, Wusa. Later. Hey everyone, my name is Joshua Reynolds and welcome to the Invoke RE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you.